Hello everybody and welcome to the Homework Helper for section 2.1. Victor here, help guide you through this. Alright, in the very first section here, we're talking about graphing exponential equations. And it wants us to limit our domain from -4 to 4, right? Where all x's are between -4 and 4. So what does that mean for our equations? Well, let's go ahead and look at this real fast. So when we're talking about from -4 to 4, we have to kind of look at what our graph is doing here. And it looks like this is 5, 1, 2, 3, 4, 5. So we're only actually interested in graphing from -4 to 4. So along that pink area is going to be our domain. -4 to 4, -4 to 4, -4 to 4. You don't have to highlight it like I'm doing, but I think that's useful to try to understand what we're talking about when we're talking about our domain from -4 to 4. So when we're thinking about this, it wants us to graph exponential equations, and I think it's important to remember exactly how exponential equations work. So when we're talking about exponential equations, we're going to have y equals our starting value, which would be our n sub 0, or as I like to think of it, our 0th term. If there was if 0 were our answer, or if 0 were our x, what would our y be? And so that's going to be times our constant ratio to the x power. Now, this is our start point, and this is our growth rate, okay? So when we're talking about something like an n sub 0, or our start point, that's going to be where it is along our y-axis, okay? And we'll go from growth rate in just a second here. But when I'm looking at this one here, it says y equals 2 to the x. So when I'm looking at my general form, well, I have the 2 to the x, right? I know that my growth rate is 2, right? My constant ratio, as it's sometimes called, constant ratio, is 2, because that's the number that's being raised to the x. So that's telling me I'm doubling each time. But what I don't see is I don't see a number right here, right? There's no number in front of that. So I have to assume that it's 1. So my n sub 0, or my starting value, is 1, which kind of makes sense. We can multiply anything by 1. There's always an invisible 1 multiplying by everything. So what this tells me is I'm going to start at 1. I'm going to start at 1 because that's the invisible number that's there, and I'm going to double each time. So 1 doubled is 2, 2 doubled is 4, 4 doubled is 8, and 8 doubled is 16. And I don't have to go any further, okay? I don't have to go any further than that because my domain ends at 4 here. But how do I get those negative numbers? Okay, how do I figure out what my negative numbers are? Well, I can think of it this way as well. I can think about my negative exponents. So for example, at -1, for this example, 2 to the -1st power, well, we learned last chapter that that's the inverse. So that's going to be 1 over 2, or a half. So when I'm at -1 here, I'm actually at a half, which is right there. Okay? Well, what about the next one? What about at -2? Well, that's going to be 2 to the -2 power. Okay? Well, 2 to the -2 power is 1 over 2 squared, which is a fourth. So it's half of a half. So it's here. And this pattern will continue. A half of a fourth would be an eighth, and a half of an eighth would be a 16th. And you can see it gets so small, you can't even see it there. So this is what our function looks like. It's these tiny little fractions that slowly get bigger till we get to 1, and then we start doubling all the way up. Okay. Now this one does the same thing, except the only thing that's changed is our start point is now 2. So we're going to start at 2, and then we're going to double it from there, okay? But I do want to focus on this other one here, because this time our constant ratio is a half, okay? And we still have that invisible 1 out here, so we know that our starting point, or as I like to call it, the n sub 0, is at 1. So we start at 1, but I grow by a half, so what's half of 1? Well, half of 1's a half. What's half of that? Well, that's going to be a quarter. An eighth, a 16th. Oh, but what about if I go the other way, right? What if I go back and instead I'm looking at -1. Well, think of it this way, 1/2 to the -1 power. We know that when we take something to the -1 power, we flip the numerator and denominator. So if we flip the numerator and denominator here, that's going to be 2. So this is going to be 2. Okay. What about 1/2 to the -2? Well, I'm going to flip it, so it's going to be 2 squared, or 4. So that's going to be at 4. And what I want you to see is it's following the same pattern as number 1, except instead of doubling, we're halving. So it kind of flips around the y-axis. So we're seeing that relationship go the other way. 8 at -3 and 16 at -4. So it does a little thing like this. Okay. So that's how we graph those. And again, this one, we're going to start at 2 before we start halving. And so that'll give you a slightly different line. It'll shift it just a little bit. We can go from there. And then it'll ask you to compare them. All right, next up. It kind of gives us a definition of a logarithm here. We kind of played with them just a little bit. I gave you the most basic definition, but we want to really understand logarithms more in this section because this whole unit's about logarithms. And so here we have that definition of a logarithm. For all positive numbers a, where a is our base, okay, we're talking about positive bases. Where a is not 1, the base is not 1. It's any positive number that's not 1. And all positive numbers x, where x is the outcome, we know that y equals log base a of x means the same as x equals a to the y power. So let me write this out just so that we can really see how this works. So if y equals log a of x, that's the same thing as x equals a to the y power. Okay, so let's just make those connections real quickly here. So log base a of y is our exponent, is the exponent of the base, where when we evaluate it, we get x. Okay, so let's see how this actually works out. Okay, there's some questions here. Why is it important that the definition of a logarithm states that the base of the logarithm does not equal 1? Well, think about it this way. Okay, so if we have y equals the log of base 1 to x, well, that's the same thing as x equals 1 to any y power. Now, 1 to any power is 1, right? 1 times 1, however many times, 1 times 1 times 1, y times is always going to be 1. So x and y would always be 1. So if the base is 1, everything's 1, okay? So that's not really a useful function for us. We know 1 is 1, and there's nothing that changes, so why bother with that? I'll let you answer these other ones on your own, have you think about them, but I want to kind of think about this, okay? I want to think about what's going on here with these exponential forms and trying to turn them into logarithmic forms. So I'm going to put this right back here. Okay, I'm going to put this right back here. And so this is all about redoing our recipe. So no, this is 5 to the 4th equals 625. So it's already in this form. Base to the y equals x, okay? So my base is 5, so that means I have to have log base 5. And then it's being raised to the 4th power. That's my y, so that needs to go on the other side. And that means log base 5 of 625. So what it's saying is 5 to what power is 625? 4. Okay. Let me try it again. So we have a base of 1/2 to the -3 equals 8. So now we have an issue where we have negatives, and we're not supposed to have negatives to work with our logs, right? That's one of the things it told us is don't have negatives. So what I want to do here is I want to transform this so it doesn't have a negative. And so the way I could transform this is, well, I know that that negative causes my numerator and denominator to flip sides. So this would be the same as 2 to the 3rd power. Great. Now it's in the form I know how to work with. X equals a to the y, right? my base to the third. Okay, sweet. So I know it's going to be log of my base, okay, log of my base, which is 3, or I'm sorry, which is 2. Okay, the power there, 3, goes on the other side. 8 goes, what did I point out? Yeah, x to x, x to x, right? 2 to what power is 8? 3, okay? So just be mindful of that. That's what we're going to be doing here. So this one, too, has a negative power, so you'll have to think about that one, figure out how that's going to work. You're going to want to leave your base kind of how it is, but we'll go from, I want you to kind of toy around with this one. This is going to be an interesting one to work with, given all the rules that we're given. Our x has to be positive, the base has to be positive, et cetera, et cetera. Okay. Next, we're going to be doing a review where we're going to be writing everything as an integer or a simple fraction. So anything to the 0 power by rule is 1. So that means this is 11 times 1, which is 11. The negative is telling us to invert it. So this is going to be 1 over 3, but it's a negative 3, so negative 1/3. That's a simple fraction. This is going to be the same thing, 1 over 4 to the third. And then I think it wants us to write it as an integer or a simple fraction, so we have to expand this. So that's going to be 4 times 4, which is 16, and then we're going to multiply that by 4, which I believe is 64. Let me double check. 16 times 4, okay. 6 times 4, 12, 18, 24. Times 4 is 4 plus 2 is 6. Yep, 64. So this is 1/64. Look at this ugly duck, right? 9 divided by 2 to the negative 1. Well, remember the negative causes it to flip. So in a case like this, where it's just on the 2, right? It's not on the 9/2. It's just on the 2. So that's kind of the same as saying 9 over 1/2, right? Because I'm going to flip it down and raise it to the first power. But when I'm taking a fraction and dividing it by a fraction, that's the same as multiplying it by the reciprocal. So that's the same as 9 times 2, right? 9 divided by 1/2 is the same as 9 times 2. How many halves go into 9? Well, 18 do. Okay. So that's one way of doing these. But a rule that I think of is whenever I have a fraction like this, right? Whenever we're looking at a fraction and we have anything raised to a negative power. So if I had a to the negative 1, b squared, c to the negative 3, all over d to the negative whatever, 4, doesn't matter. When I think of the whole fraction, what the negative is telling me to do is to take whatever that is and move it to the other domain of the fraction. If it's in the numerator, it goes in the denominator. If it's in the denominator, it goes into the numerator. So when I think about this, okay, a to the negative 1 means it goes down. B squared, that's going to stay above. C to the negative 3, that means that's going to go down. C cubed. D to the negative 4, well, it was down, so now it's going to come up. D to the 4th. And so that's kind of how I think about those. The negative tells me that it's going to dance to the other side of the fraction. It's going to go from the numerator to the denominator to the numerator. All right, that's going to be it for this one. They do get complicated, but just remember your rules and apply them in order. You know, I'm looking at this one here, that 0 applies before everything else, so make sure you're doing that. And good luck with these, and we'll see you tomorrow.